Hi everyone, this is Maths4Uni. This is question 5 from lecture 11 of our Udemy course, Bridging the Gap to Maths at University. If you enjoy this content, then please consider liking and subscribing, as well as checking out our full Udemy course. The link is in the description. The question says, sketch the domain of the function f of xy equals the square root of 1 minus x times y in the xy plane. Now, to start with, we know that for a square root to be well defined, its input has to be non-negative, i.e. it can be positive or 0. This means that we need 1 minus xy to be greater than or equal to 0, i.e. by rearranging, xy has to be less than or equal to 1. We begin by sketching the graph xy equals 1 and then identify regions that satisfy this inequality. So in this diagram, we have sketched the graph xy equals 1, which is equivalent to y equals 1 over x, as we have sketched here. And then for xy being less than or equal to 1, we need x and y to be sufficiently small, at least in their product, because we have x multiplied by y being less than or equal to 1. This tells us that the region we're interested in is the region inside the curve in some sense, i.e. this region inside bounded by this curve. So if we put on some lines to shade it in, it is this entire region here. This is the domain of the function square root of 1 minus xy, because we need the input to be non-negative, and then this gives us this region here. If we then wanted to go further and actually sketch this function in xyz space, we would then know that the xy plane would need to look something like this, and outside of this region the function wouldn't be defined, and then we could sketch on to the z-axis into the third dimension what this function actually looks like on this domain. If you found this content helpful, then please consider liking and subscribing, as well as checking out our full Udemy course. The link is in the description. Thanks for watching, and goodbye for now.